Hi, everyone. Good afternoon. Our group is going to be presenting on a case study in the use of bioremediation to address terrestrial oil spills. My name is Shatija, and we have Kelly here, we have Ahmed, we have Darby, we have Court, and we have Sarah. So in general, oil spills can be very dangerous and they last for decades because of all of the organic contaminants in the oil. Degradation of oil, especially when it can't be controlled and has spread across all of the land, gets really hard to control. And so it also affects all of the vegetation in the surrounding area. And as a result of that, we have a terrible effect on human health, animal health, and the economy can be damaged, especially because oil spills can affect farmland, they can affect animal grazing areas, they can affect an industrial area that can then be off use of commission.
And the damage can take a long time to recover for the economy, especially when an oil spill impacts an aquatic environment that can impact ports and shipping activity, as well as the environment and animals. Next slide, please.
When an oil spill occurs, there's a variety of solutions that can be utilized. The first one would be natural degradation, so do nothing. To use this one, it's really inexpensive, but you do need low contaminant levels and fast weathering of the environment. A second solution is to pump out the oil. This method's extremely expensive and causes significant damage to the site. It's pretty invasive. A third one is marsh burning, which you can see in the upper right-hand corner. This is effective when you have high contaminant levels, but as also has significant damage to the environment. Therefore, bioremediation is a really good option as an inexpensive alternative that's relatively non-invasive to the site. Next slide.
For this project, we're considering a hypothetical oil spill happened off the Keystone Pipeline in North Dakota with about 380,000 gallons of oil spilled. This would have affected over 200,000 square feet of land, including 22,000 square feet of wetlands. The chemicals that are problematic in an oil spill are heavy metals, benzene, toluene, hexane, heptane, and cyclohexane. Next slide. And the climate around North Dakota is very important for bioremediation. North Dakota has a very variable climate, with it getting up to 90 degrees in the summer and below freezing in the winter. Next slide.
What is the magnitude of damage? The Keystone Pipeline affected nearly 22,500 square feet of soil. The main pathways that it could have taken were rivers, wetlands, shallow groundwater aquifers, and that were used for drinking water. And it's near the Ogallala Aquifer, which is shown right here on the map. This is where the oil spill occurred. And that accounts for nearly 30% of the county's drinking water. So contamination of this reservoir would generate potential dangers to millions.
Roughly 50% of the lightweight compounds, which can be the most toxic in the contaminants, evaporate in the first 12 hours. So after this, if contaminant levels were originally low, the area is ready to be sowed with plants. Next slide. However, if the contaminant levels are still really high, there's supplemental technologies that can be utilized. One of these is sorbents, which you can see on the left, which can be used to collect additional water that's on the additional contaminants that's on the water surface. Fertilizer salts and acidifying agents can also be used to increase the uptake of heavy metals. Next slide.
So we proposed phytoremediation in this project, and there's a couple of processes by which phytoremediation can occur. We have rhizofiltration, which is the adsorption and absorption of pollutants from water. We have phytodegradation. We have phytostabilization, phyto extraction, and phytovolatilization. And specifically for oil spills that contain heavy metals and a lot of organic compounds, phytodegradation as well as phytovolatilization are the most common methods that are involved for organic contaminant degradation. And here is another image that highlights the different kinds of chemicals and compounds that can be phytoremediated. And so we have organics that include polyaromatic hydrocarbons, PCBs, and dioxins. We have root uptake of metals, radionuclides, organic compounds. Again, we have chemical degradation of the same compounds. And since metals can't be degraded, they're accumulated in the plant tissues.
Next, we'll go a little bit into the design portion of the presentation. We need to utilize plants that are both tolerant of high hydrocarbon levels and high heavy metal levels. For a hydrocarbon remediator, maize, alfalfa, and sunflowers are really good choices. North Dakota actually grows 78% of the United States sunflowers, so the environment is pretty ideal for their growth. As a heavy metal remediator, the aster family is actually the largest flowering family in the U.S., and there's 3 different species that are native to North Dakota, which includes the smooth blue aster, which is the picture on the left, oxeye daisy, and the dandelion. Next slide.
The most effective phytoremediation plan that there is for this type of soil removal is going to be the rhizosphere bioremediation, and this method removes organic contaminants in media such as the soil, sediments, and land applications of wastewater. And then after the design, you're also going to need to monitor the area, and this is going to require a 5-year monitoring plan. This includes travel and administration, data collection, reports, and sample analysis.
There are many advantages associated with this remediation plan. Next slide, please. Both phytoremediation and bioremediation are safe and non-invasive techniques for the environment and potentially the only environmentally friendly methods for petroleum hydrocarbon removal. On account of this safety, these remediation techniques typically have public acceptance on their side. Next slide. Phyto and bioremediation achieve high levels of petroleum hydrocarbon degradation in both field studies and laboratory environments, some even boasting up to 98% removal. Next slide, please. Phytoremediation is also much cheaper than conventional methods, which without having to sacrifice efficiency. Next slide, please. There are some major disadvantages with this plan. One being that the remediation plan is in a very cold climate. The lower the temperature, the more crude oil viscosity increases, making it less volatile and less water soluble, which can slow down the biodegradation process substantially. North Dakota winters drop to temperatures as low as 0 degrees Fahrenheit, potentially causing delays in bioremediation during the coldest months of the year. Temperature also poses a limitation in the phytoremediation process. Non-native plants like sunflowers, maize, and alfalfa are all susceptible to the frost and freezing temperatures prevalent during these cold winters. Next slide, please. The efficiency of removal is also limited by the growth rate and extraction rate of the plants, which is oftentimes relatively slow compared to conventional treatments. The plants must also have the capacity to root deep enough to reach contaminants. The availability of nutrients in the soil is another factor that may limit growth, as most sites require nutrient supplementation. Next slide. With this plan, there is always the risk of pollutants spreading. Rainfall can cause contaminated areas to produce harmful runoff and reach into the neighboring wetlands ecosystems. Moreover, North Dakota is a massive agricultural state with farms spanning over nearly all of the landmass. If the remediation plan becomes delayed for any reason, contaminated runoff could not just reach the surrounding wetlands, but also farmlands, posing a serious threat to environmental and public health. Additionally, animals may accidentally ingest the plants, allowing for the contaminants to enter the food chain and cause more complications. Next slide, please. Further challenges arise when the limited availability and usability of the land is considered. In order for phytoremediation to work effectively, it must cover a large area of land. Financial support for restoration, as well as involvement and support from site owners, farmers, Local peoples, remediation experts, technology providers, and consultants is required for expansive operations of this nature. Next slide.
Some specific unexpected shortcomings of phytoremediation include the fact that you won't have any phytoremediation if the pollutant is not in the zone of influence of the root. So in red, you have the pollutants that are not close enough to the root to be remediated, and the ones in purple will be remediated. Another thing is that high concentration of any contaminants or compounds or nutrients can shock the plant, leading to phytotoxicity. And that would also cause plant decay, which can cause re-entry of the contaminant that's been taken up by the plant into the environment if not monitored constantly. And since it's very hard to control environmental and laboratory conditions, researchers may not be able to identify the exact concentrations after which plant may die of toxicity. Multiple factors affect plant growth. And so if any of these factors, environmental factors fluctuate, then we may not be able to control the plant growth, which will also alter the phytodegradation efficiency of the plant, leading to inconsistent phytoremediation. And also, as mentioned before, environmental conditions cannot be precisely mimicked in the lab, which could lead to some confounding variables in the environment that may not be accounted for in lab, leading to an inability to efficiently phytoremediate in the field.
There are also some potential legal ramifications for an operator of a pipeline that causes a spill. They may be subject to enforcement from both government entities as well as community groups through the citizen suit provision of the Clean Water Act and RCRA. As a result of a successful suit, the pipeline operators may be subject to injunctive penalties, whereby they need to change their operations and improve the technology they use, as well as civil penalties. Under the Clean Water Act, those penalties are up to $52,000 per day per violation. And for example, a few years ago, a pipeline spill near Santa Barbara resulted in penalties of $24 million overall. Thank you very much for listening to our presentation on phytoremediation.